here we want to ask the million-dollar question. How do you make AI work not only for one project or two projects in your organization, but across teams, across departments, in a reproducible and scalable ways? So that's the focus of our session today. And today we have myself, Ronald, I'm from Mantel Group, and we have Josh Ferre from Databricks to talk about our observation from our clients across Australia and New Zealand region and beyond. What are our key learnings in their barriers in the AI journey? And what are some battle-tested tips and solution frameworks that we help the clients apply and conquer those barriers? So those will be the focus of this session. And after a quick intro to Mantel Group, we'll look at the AI trends we observe across the markets, and then look at the barriers, and then share with you the key framework and also the accelerators we're going to tackle those problems. So without further ado, let's hand over to Josh to kick us off with the session. But let's first start with a quick intro to Mantel Group. So Mantel Group was established in 2017, and we are a leading independent partner helping organizations to create solutions and to make the business better. We have a growing capability of 4 pillars: digital, cloud, AI, ML, and also the cybersecurity. So we help the clients solve problems with a comprehensive lens. And also we know Databricks. So we are award-winning partners in developing and deploying solutions on Databricks. And we are the only organization in Australia to have a dedicated Databricks practice to help craft large scale of work in solving problems with Databricks. And we are also among the first partner in the region to reach the elite level partner status in the past years. And so what we see today from in session will be a shared learning from the Mantel Group and also Databricks in our journey in helping customers get onto the AI journey to get up to speed. So, all right, so let me now pass it to Josh to kick us start with the AI trends.
Awesome, thanks Ronald. So what are we seeing out in the wild today? Many organizations are actually starting to really understand the business benefit that can come from leveraging AI and machine learning, okay? To the point where over 85% of organizations, if you saw Ali's talk at the start, are starting to leverage generative AI in their organization, whether it be experimentation or otherwise. But not only Gen AI, more classical and traditional machine learning as well. Over 84% of organizations that we've seen and dealt with are actually got these ML models in production. And as a result of this, we're seeing a wide, vast array of projects being done in businesses, right? From proof of concepts through to production deployment. Because of this, there are a heap more unlocked use cases, not just in Gen AI and NLP, but in that classical and traditional machine learning side of things. And what we're seeing is they're actually really unlocking business benefits, tangible outcomes, whether it be operational efficiency, automation, or customer experience. And so when you look over on the graph here at the right, you can see over 70% of the organizations really find that those key areas are where they can find the greatest potential, all right, over the next coming years. But because of this, there are 2 more real key trends and consequences of this, right? All these new projects means that your internal machine learning teams or data science teams are being bombarded with requests to actually do something and help the businesses. But because of this, they're so swamped, there is now this growing desire to actually democratize that skill set and those models through to the broader business. And you would have already heard Ali talk about how Databricks hopes to actually democratize that. But because of this, there's also a really growing need and importance being placed on data quality and reliability of that data and the actual underlying foundations and engineering pipelines that exist there to help drive that forward. And because of this, what we're seeing is that the majority of the businesses in Australia and New Zealand, and I think this is actually pretty relevant worldwide, is that they're stuck in what some like to call POC hell, right, where it's this constant experimentation, not really showing that business value and just trying new things out for the sake of trying new things. And what we're hoping to see is then by producing repeatable and reusable frameworks, you can actually scale where you're using AI and machine learning throughout your entire organization all over the place. And the reason for that is that building the ML model is the easy part. Right? There's plenty out there now. We can see there's all these open APIs that are being developed to leverage these models. The true challenge actually lays in building the framework and the foundation across that organization. Not just the tools and technology, but also the people and the processes that are involved to help scale this out. And we're seeing over 27% of those organizations have actually changed their operating model altogether. All right? Whether that's placing a greater emphasis on a CDO or CTO role or CIO role, or developing even new roles that have every other alphabet letter there too, right? Like CAIO, right? The new Chief AI Officer. It's a fairly new role that's come in. So what are some of those barriers that are actually there and that we're seeing to help or really struggling for those organizations? I think the first, there are 5 really key ones. The first one, organizations really lack scalable infrastructure, right? Many organizations aren't even leveraging the cloud yet, let alone a really cool data platform like Databricks. Right? People are doing notebook work still on their laptops, makes it very hard to scale that out. Secondly, AI doesn't live in a bubble, okay? You need to be able to interoperate and integrate into business processes and other technology systems so that you can actually drive impact. You would have saw earlier today with the agents demo that Casey did, and she nailed the bug debugging as well. Being able to start, not just have a model, but actually produce a tangible outcome for the business. Thirdly, there is this lack of understanding of AI and people's capabilities in the business. Okay, sometimes you'll have people who are maybe underconfident or worse, overconfident in their skill set. You might have a business analyst who thinks, I can go and use all these cool new simplified technologies, but then without understanding all the logic underneath it, it could result in poor performance or even worse, catastrophic outcomes. I think we've all seen the chatbot from Chevy, where it actually suggested to buy a Ford Ranger, or there was another chatbot that gave him a car for $1. Same concept here, right? And so that can then create distrust across the organization and reduce or inhibit your ability to actually scale and build more and more models. Fourth, once you start building those models, as a former data scientist, you always get stuck on trying to have the most accurate model. And so you're always iterating, trying to get that 99% accuracy. Because of that, you don't actually move it into production and deliver that business impact. And then finally, fifth, not bringing in governance and the broader business early enough. You make this model, you're like, yes, let's put this into production. And then someone's like, hang on, you're using really sensitive data here. Have you considered X, Y, Z? I need to have the security team involved, and then that delays it another 6 to 12 months, because we all know how security likes to take their time. So without any further ado, I'm going to pass it back to Ronald, where he can give you some actual tips and tangible things that you can take to your business to help avoid those pitfalls.
Cool. Thanks, Josh. So after hearing all these barriers, the question is, what are the tips or some solution framework that can help an organization prevent and avoid the pitfalls? And in our experience, it comes down to some core requirements to making AI succeed in your organization. And it comes to 3 pillars of people, process, and technology. So first is the people pillar. So it's all about bringing the right group of people into their relative position in an AI project to make sure they understand their roles and responsibility in driving AI use cases in the organization. You need a skilled technical team and also business people who understand the impact and usage of AI in various parts of your organization to make sure that the benefits, the usage of AI use cases are properly communicated, to make sure knowledge is shared, and also an AI culture is being cultivated. So it's always start with the people. And then it's the process pillar. So by process, we mean some kind of repeatable and standardized ways of working procedures or workflows so that each project, each team can follow to guarantee a quality output by the end of that process journey. So you need to ask questions, for example, such as, is every AI project following a proper MLOps workflow standards? And have we made it easy for each AI project across all those business teams, easy to follow the risk compliance standards? So making sure these processes are there, properly set up as early as possible, can avoid many of the downstream efforts of bringing back, fixing things, bringing back to the standard, which can be actually causing more issues and bringing inconsistency. And then finally, it's the technology pillar. So having the tech stack that supports your people to follow that rigorous, repeatable process is key to the AI success. And this technology should be covering the entire spectrum of data ops, DevOps, and MLOps. And most importantly, the technical decision we made here should be guided by the requirements from the people and the process perspective. So let me put an example. Imagine an organization that has many sensitive data across different departments or different geographical locations. It will be necessary for the people in that organization to be allowed to develop AI, test AI in a federated way in their own department and following a process that allows them to further push forward their progress without the need to really bring the data across the boundaries. So following these requirements, providing the organization a technology stack that support, for example, federated data querying or federated machine learning model building will be key to success for the organization. So these three pillars really can be used as a high-level checklist to assess your organization's AI maturity and to see what are the gaps and what are opportunities forward to move forward to a more successful AI implementation. And I mentioned the word foundation a few times in the talk, and what does it actually mean to build an AI foundation? So to start with, the AI foundation always start from building an AI roadmap. So such a roadmap indicate what are your priority goals for the next quarters, for the next years, what AI capability you want to achieve. And this should be aligned properly with your organization's priority because it's key for you to get the internal business support and endorsement to push this AI capability growth forward. So it's very important to spend enough time early on to make sure you get the direction, the roadmap strategically right before you move on to the next step. And the second component of this foundation is the MLOps foundation. So it covers not only the technology, which we'll talk about later on, but it also should cover the people, the process consideration of getting the right persona, user groups to interact with a new uniform MLOps platform. So we'll talk about that in the next few slides in a minute. And upskilling and training, it is important to share your AI knowledge within your organization, not only for the technical teams to enable them to properly run and manage AI projects, but also for the business team to understand the impact of AI. It is important because not only you need those endorsements to make sure you have enough support from all areas of a business, but it also allows you to remove the reliance on a few individuals who knows AI and which become the bottleneck of your AI progress. And also by upskilling your entire team, you can quickly scale up how you can push the AI progress in various parts of the organization in parallel at scale. So upskilling is definitely a key enabler here. And finally, the fourth pillar in this AI foundation is the responsible AI toolkits and the framework to be established. So it covers things like the biases and the ethics consideration of the AI service you are building. And it should happen as early as possible. On the market, there are many toolkits and frameworks that the organization can use to implement, but timing is the key. We see examples of retrospectively trying to fit existing AI use cases into some responsible AI framework, and which can be time-consuming and cause quite a lot of downstream issues when you do it afterwards. So it's very critical to set up this responsible AI practice right from the beginning. when you build a foundation. So once you have the foundation right, it's time to move up the pyramid. So starting with the uplift stage, you can start migrate your AI models into this solid AI foundation. You can do some AI health check to make sure that your existing AI services have quite high quality and comply to all the standards you just created. And then they can proceed to the build stage to keep continuing building POCs, building MVPs, and eventually bring those AI services into production. So one thing to note is that although the arrow here in this pyramid is one directional, but in practice, it's very cyclic and iterative process for you to bring your AI services all the way to production. And now I want to further deep dive into the MLOps machine learning operation component of this AI foundation. And when we talk about the AI development lifecycle, it covers the end-to-end workflow and the infrastructure that is used to support your machine learning use cases. And the first component of this AI development lifecycle is the inner dev loop. So this is usually what people think about first when you design your machine learning workflow. It is covering everything from your data preparation, feature engineering, all the way to model deployment and monitoring. And the key here in this inner dev loop is you want to make sure that you have a repeatable best practices that allows each personas, like engineers, data scientists, data governance officers, and business stakeholders to easily use, interact, or observe this entire machine learning pipeline. And in an ideal scenario, working on a unified platform. And at the same time, there's another outer dev loop that is often not receiving the adequate attention it actually needs. So this outer dev loops considers how you structure your code base and how you set up your infrastructures so that it's really reusable across your AI use cases. And also it's about the CI/CD workflow so that it can automate the task to make sure that every AI development steps you take forward is properly guardrailed and tested before making its impact into production. So this outer loop, you need to ask questions such as whether your machine learning workflow platform is designed to be able to handle a lot of concurrent AI use cases and production workloads, and whether you have the proper infrastructure that is sitting there with a proper capability to handle all the use case needs. And finally, besides the inner loop and the inner dev loop and the outer dev loop, this AI development lifecycle and the corresponding MLOps platform need to help you reduce the integration overheads that usually happens when you bring new AI offerings into your existing systems. So imagine each AI teams need to source their data from some siloed databases, and each team need to communicate with the business team to establish some integration layer to the downstream BI or other type of application. And all those repeated efforts should be abstracted away by a properly defined, designed ML platform so that you can have a unified integration layer to help you connect to the upstream and downstream systems. So that's what in an ideal world where we have an ML platform to help us streamline and making entire AI development lifecycle much smoother. And we will, in the next few slides, look at how we actually to help cost organizations implement that using some of the technical accelerator learnings we had along the journey. All right, so after looking at this solution framework, it's time to have a deeper dive into what we are actually going to implement when we bring a customer up to speed in their AI transformation journey. So imagine there's a company A that is really seeing the value of AI, and it has already identified some business use cases that can be solved by AI machine learning. But they haven't implemented anything yet, and they want to leverage some reusable MLOps artifact without reinventing the wheel every time they have a new use case. So that's the key ask for organizations like this company A. And what this company A has done a good job already is that they have identified a machine learning use case to start with, which is critical. And in this case, we use the example of a taxi fare prediction use case, as it is needed by many of the business teams inside this company A. And the company also decided to use a central operating model, which means there will be a central team managing a central repo of this prediction model to serve the many business teams and other business stakeholders across the organization. And also the company A is aware of the need to create more infrastructure resources, in this case, Databricks built on top of Azure for this new machine learning operation capability. And just a note that we choose Azure here as an example, but the same concept is applicable to all the other cloud providers as well. And this is what the company A want to implement, the MLOps best practices as shown in this diagram. So there's some key elements I want to quickly highlight here. So in an ideal MLOps best practice, you want a separation of the development workspace, testing workspace, and the production workspace, so that your experimental work and your production workloads are properly isolated and secured. And also second, you also want to have your data in different catalogs or containers to be properly isolated, so you can apply the proper access pattern for all those future personas across your organization to access and interact with the pipeline. And at the same time, you want to have an automatic CI/CD, as on top of the screen shows, to help you efficiently test all those new features you added to your machine learning pipeline, and streamline and automate these testing and then deployment actions to make sure that you can always get your pipeline up to date and deploy to the business for serving the use cases. So this is the ideal conceptual MLOps best practices that company A want to achieve. But when it comes to implementation, there are usually many nuts and bolts, as we observe in many organizations' journey. So for example, access pattern for different persona is actually trickier than maybe people expected. So imagine you need to onboard people like engineers, data scientists, and business stakeholders, analysts onto this platform. How do you make sure that when everyone log into these workspaces, they are seeing the right data they have access to and not the one they shouldn't be accessing to? And how do you control making sure that they have the right access to the pipelines so that they don't accidentally modify some other team's important production pipelines, things like that? So this configuration can be more time-consuming than originally expected, and it can often involve long discussion between data, infra, and security teams. And the resulting manual configuration is not only time-consuming, but can also be prone to human errors. So that's the first example. And the second example is about the varying release patterns that is required by the company. So for example, imagine for company A, taxi fare prediction model. Different teams in different geographical locations, they might have their own needs, their own models, and their own requirements for when to update and refresh the models. So how does these different model release patterns and schedule fit into a single MLOps platform? How does this single platform support those different requirements is the key design question people need to factor in when you build up these machine learning best practices. So there are many more of this kind of nuts and bolts, which makes it actually trickier than expected and really effort demanding when you implement a fresh new modern MLOps platform in an organization. And that's why we come up with the accelerator that we're going to show in the next few slides to help organization quickly kickstart, factor in all this consideration and quickly get to ground and make things work. And the solution, as I described, is a production-ready MLOps platform accelerator that leverages Databricks, Unity Catalog, and all the other awesome features there. And this accelerator has two components. The first one is the infrastructure accelerator. So it streamlined the creation of the different workspaces, the Unity catalogs, the user groups, and also the corresponding access pattern for those user groups right out of the box, so that you make sure that everyone have the right user privileges when they open up their workspaces for the first time. And second component of this accelerator is the MLOps component. And this is built on top of the Databricks MLOps stacks offering that really make it easy for you to deploy all the notebooks and the source code logics of your end-to-end machine learning tasks, like in a really reproducible way, and also with automatic CI/CD right out of the box. So that's the accelerator component we are going to take a look right now. So let me jump to first the infrastructure accelerator we are seeing. So on the left side of the screen, this is our repo of the infrastructure accelerator. And it has the modularized Terraform code for you to configure and specify which infrastructure component you want to create and deploy. And importantly, as you can see here, there are a set of YAML config files for you to easily specify for the dev, testing, and prod workspaces, how do you want to establish and construct the fundamental Azure resources? For example, the resource groups, the service principals, and all the storage accounts. And furthermore, you have another set of YAML file that controls the Databricks resources that you are going to create and deploy in the workspaces. So let me click into one of the YAML file to show you as an example. So this YAML file specifies what resources and what user groups will be created for the production workspaces. As you can see here, it's easy for you to specify what are the user personas, such as engineer, tech leads, or machine learning scientists that can straight away access this workspace. And also later down the file, you can easily specify how these user persona groups should have their Unity catalog privileges across all those different catalog and schemas. So it makes sure that you have the right permission coded as a reproducible and reusable infrastructure as code script, so that avoid all the human errors from manually key in and setting this up using mouse click here and from the UI. So that's the benefits of having everything here configurable as the YAML file. And the way to deploy this accelerator is really simple. We have a CI/CD pipeline that basically automates the steps of Terraform planning and also the Terraform apply stage, so that all the configuration we just talked about in the YAML file are automatically tested for their validity. And then with the human in the loop checkpoints here, so that the cloud engineer, the infrastructure engineer, can make sure that everything works fine before really deploying and create those workspaces. So the resulting workspaces is what we see on the right. So as you can see that this is the dev workspace we created for this showcase. And there are also the test workspace and the prod workspaces that has been created following exactly the specification we had in this YAML file. And if you look at the catalog here, you will see all the schemas are properly created with tables and registry model sitting there for the data scientist or engineer to populate data tables or machine learning models. And here are the permissions. You can see what I mean by having the proper privileges right out of the box. So all these personas, like ML scientists, analysts, can safely interact with a workspace and do their things in this dev workspace, making sure that they don't accidentally access the wrong data in the wrong location of the catalog. So it is really handy and remove all those troublesome manual efforts into setting this up. So that's a quick glimpse of how we can easily create an infrastructure for the MLOps foundation that we have been showing in the previous slide. And then we now have the infrastructure properly provisioned. Let's take a look at the MLOps stacks part of the accelerator. So on the left-hand side here, this repo contains the accelerator we built on top of the Databricks official MLOps stack. So it contains folders for you to structure and store the notebooks and the Python source script of your entire machine learning pipeline, like feature engineering or deployment, and also, of course, the model training. And all these script and resources are further captured and specified as a Databricks YAML file, which help you to construct Databricks workflow jobs that orchestrate your machine learning tasks. So for example, take this orchestration job, for example. Here is how an engineer or data scientist can look into how he wants to orchestrate the creation of some demo data, the creation of some features, and then the model training, validation, and deployment steps. So all easily done within a YAML file that can be understood by the Databricks CLI, and then turn them into the corresponding workflow jobs in the workspaces. So the result deployment after you run some simple commands from your terminal is what we see on the right of the screen. So this is the dev workspace. So you can see that for a data scientist like myself, I will have all this workflow deployed as Databricks workflow jobs. And it includes end-to-end orchestration job. This is for everything from data, feature to model deployment and inference. But also you can flexibly design partial jobs. For example, batch inference job without retraining the model. It is very helpful for many of our client organizations to have this partial versus end-to-end workflows so that they can properly schedule them following different cadence. For example, retrain your model monthly while making batch inference every day or even every hour. So if I click into the orchestration job, for example, you'll be able to see all the components, the task components that constitute the jobs. As a simple to understand RAG diagram, exactly following the logic you specify in a YAML file. So it is super handy for the data scientist and machine learning engineer to construct whatever job, even experimental job, using this way in the dev workspace. So let me go back to the workflows. Yeah. And after the data scientist and engineer is happy with their new features, for example, what they need to do is to simply create some pull requests in their GitHub repo. And those pull requests will also trigger the built-in CI/CD logic that comes with this MLOps accelerator. And those CI/CD logic will automatically test the new feature branch you created, making sure all the unit tests and the integration tests pass before successfully merging into the main branch. And then when you want to move on from the testing stage into the production stage, what you need to do is very simple. You just need to create a new merge request to merge your main branch into a release branch, and that will trigger the deployment of your pipeline into the prod workspace and the execution and the serving of that production model pipeline. So here's just one example of our pull request of a new up-to-date schedule for our end-to-end job. So once you merge it into the release branch, just like what I did here, the CI/CD pipeline will soon pick up this event and trigger the corresponding CI/CD actions, as you can see in your CI/CD provider. In this case, we are using Azure DevOps. This one is the freshly new deployment to production, just triggered by our pull request into the release. And this deployment into production will then trigger the job deployments and the execution in the prod workspace to run the end-to-end pipeline easily. So that makes the entire AI development lifecycle for a developer to be super easy, moving from dev to testing to production, all because we have this handy MLOps stacks accelerator to begin with. And also these files, the YAML file-driven approach in this accelerator and also the previous infrastructure accelerator provide you a good blueprint, or you can say a checklist, to make sure that all your configuration from the infra side to the machine learning pipeline side are all making sense, valid, secured, and open to auditing and discussion by your data teams, infra team or security team. So it's a very transparent and traceable and reproducible way to build up your machine learning operation foundation. All right, now we have seen that the production end-to-end orchestration job is up running, which is great, and it will be executed on schedule for the every day, every hour, based on what you specify in the YAML file. All right, let's get back to the slides. And here's a quick summary of the technical accelerator we just showcased. So this end-to-end infrastructure to MLOps accelerator is a good starting template for you to quickly get up to speed to move your AI use cases into a modern and robust ML platform. And they're actually very fast to use as well. So in our testing, both the infrastructure component and the ML component can be set up within 30 minutes to create all those workspaces and the resources you just see on the screen. So it really helps like the organization to quickly bring in their models and pipeline into this ML platform to quickly start iterating and further development. And also because everything is infrastructure as code, so all the configuration is traceable, repeatable, and customizable. So we have helped some organization, for example, to introduce many human-in-the-loop checkpoints before they update or release the pipeline. So making sure everything's right before they roll out the next version of a model. And we have also helped organizations to introduce some advanced configuration logics inside the infrastructure and the MLOps side of the accelerator, so that their different teams across different geographic locations can share a single set of workspaces and a single repo to deploy and run their own version of the pipeline without the need to fork or copy the code base, which is really cool and really convenient for the team to have a single source of truth while supporting diverse needs of the different business team they have. All right, so I think that's bringing us to the end of this session. And here we want to share some final 3 takeaways with you guys after hearing all these, the barriers, the solutions, the accelerators of how to handle those barriers. The first takeaway is that it's important to bring all your AI services and projects into a modern ML platform, because you will want to apply the same governance structure, the same productionization workflow to all the AI projects instead of scattered and independently developed processes. And that has the benefit to reuse the valuable IP you develop for one project to all the other AI projects in your organization, which will be efficient way to use your limited resources to get up to speed in your AI journey. And also integration, you're integrating your new AI services with the existing workflows and systems need to be continuous and iterative, because you don't want to wait for some big IT migration program to finish, then to start your ML journey. So take our tech demo, for example. We use Unity Catalog as kind of the intermediary integration layer, because it can easily connect to many upstream data sources. And also, it's also easy for it to share the result to many downstream applications using things like data sharing. So it removes the frictions of potential integration points and help the developers and the end users more easily uptake the new machine learning operation foundation. And finally, it's key to share the knowledge both within your organization, within the technical team and the business team, because you need the upskilled technical team to run and manage the ML operations, and also need the business team have the right understanding of AI to provide you the right support and the collaboration along the way. So all the things we mentioned in this talk will only be possible once you have a shared understanding of the AI and have the alignment across the people, process, and technology pillars, as we mentioned earlier in the talk. All right, so I think that brings us to the end of the talk. And happy to take more questions either now or after the session.